Nested fractions. This is one of your extra credit objectives for spring break, but I thought I would do a video tutorial on it because it looks intimidating, but it's actually not. It's pretty easy, and I think it's kind of fun. And I really like this objective because it really gets at your understanding of fractions. Here we have just a fraction on top of another fraction with whole numbers mixed in, and it looks really gross. But we just have to remember a couple properties of fractions to help us make this a little bit more manageable. If I have 3 over 2, I know that if I multiply 3 over 2 by 2, or by 2 over 1, that this would get me a 6 over 2, or just plain 3. So 3 over 2 times 2 is 3. And I'm gonna be strategic with my color choices so that way you guys can see the pattern that I'm aiming at. If I have 5 over 4 and I multiply 5 over 4 by 4 over 1, or by 4, then I'll get 20 over 4, which simplifies to just 5. If I get 6, if I have 6 over 19, actually easier, over 9, and I multiply 6 over 9 by 9, which I know is 9 over 1, then I will be left with, spoiler alert, 6. And I know I'll be left with the 6 because 6 times 9 would give me 54 over 9 times 1 is 9, and 54 divided by 9 is 6. So the pattern here is that if I want to make my fraction into a whole number, if I want to multiply it so I'm left with only a whole number, then I can multiply it by the denominator, and I'm going to just be left with the numerator. Here I had 3 over 2. And I multiplied it by 2, and I was left with 3. I had 5 over 4, I multiplied it by 4, and I was left with 5. Here I had 6 over 9, I multiplied it by 9, and I was left with just 6. If I have b over a, and I multiply it by a, then I will be left with just b. The reason for that is because b times a is ba, 1 times a is a is cancel, and I'm left with just b. So the first step in these kind of problems is just to make it more manageable by getting rid of this double fraction thing that I have going on in my denominator. I'm going to multiply this denominator by a, which is this number that's in the denominator there. You can also think of multiplying it by a over 1 if that makes me feel better. And with fractions, whatever I do to the bottom of the fraction, I also must do to the top. So I multiply the top and the bottom of my fraction by a. So on top, I'll be left with, distribute this a to both of these terms. And on the top here, I'll be left with a times a over b plus a times 1, which is a. And on the bottom, I'll be left with here just b, because as we saw over here, if I multiply a fraction by something that has the number in my denominator in the numerator, then those will cancel, and I'll be left with just the top. So here I'll be left with just b plus a times negative 1, which is negative 1a, or negative a. Now I'm going to, now I've got the bottom taken care of, but I still have a fraction within my larger fraction. So I'm going to take care of this fraction. To get rid of this b on the bottom, I don't know what I'm saying. To get rid of this b that is on the bottom of this fraction, I need to multiply this by b. And whatever I do to the top, I must also do to the bottom. And if it makes you guys feel better, you can multiply it by b on this side. We're usually used to seeing the distributing term on the left, so we can put it over there. Now my new top is going to become, let's see, when I multiply b with this term, I'm going to just be left with the top because my b will cancel with the bottom b. So here I'll just be left with a times a, which I can say is a squared, plus my b times my a, which is b a, over, I'm just going to use blue from now on, b times b, which is b squared, plus b times negative a, which is negative ba. All right, now we can see that none of our answer choices here have exponents in them like we do here. But one of these choices is equivalent to this. I'm going to write this down here. A squared plus ba over b squared plus negative ba. Here in the top, both terms have an a on them, so I can factor out an a. On the bottom, both of these terms have a b, so I can factor out a b. This divided by b is going to be negative a. Another way I could think of this is if I look at this answer, which is my correct answer, a times a would give me a squared, a times b would give me ba or ab. Same with the bottom, b squared, negative ba. This is our correct answer choice. Let's do another one. All right, so which expression is equivalent to this little guy? Well, we've got some fractions within a fraction, so let's take a look at this guy on the bottom. Let's get rid of this a so we can just have, we don't have to have a fraction in a denominator. And to get rid of this a, I'm going to multiply this by, you guessed it, a. And of course, whatever I do to the bottom, I must also do to the top. So on the bottom, a is going to cancel. And on top, the a was in the denominator of both of my terms that are on top, so I'm not going to have any a's left. This a is gone and this a is gone. They're both used up. So I'll have on the bottom a minus 5. I'm just left with that top. And then here, a times 1 over 5 is just going to be, a times 1 is just a, 1 times 5 is just 5, a over 5, plus negative 1 times a is negative a, over a times 1 is a, so the a's would cancel and I'd be left with negative 1, or I could just see that this a is going to cancel with that a, and I'll be left with the numerator negative 1. And I'm almost done. I just still have this lovely 5 that is left on the bottom here. So I'm going to multiply the top and the bottom of this fraction by 5 to get rid of this 5. Five times this term is going to give me just the top. Five times this term will give me -5. And then here, something interesting is going to happen. I'm going to actually just leave this like this. And you're going to notice something to make it a little bit more apparent. I'm going to put this in parentheses. And since 1 times anything is itself, also to make it more apparent, I'm going to put a little invisible 1 outside of there. And we have a factor on top of another factor that are the same. Therefore, I can cancel those. And I'm just left with 1 over 5. Kind of crazy. All of this craziness was just 1/5. This was just a really, really, really big way to write 1/5. Can make things very, very simple. Which expression is equivalent to this one. Once again, I'm going to multiply. I'm going to write this all over here. 3 plus 3 over a over 3 over a. And I'm going to get rid of this a that's in the bottom of my fraction. And I'm going to do that by multiplying it by a. So on the bottom, I would be left with just my numerator. I would be left with just 3. And on top, a times 3 would give me 3a plus a times 3 over a would give me just my numerator, just 3. And then here, I have 3a plus 3 over 3. I can factor out a 3 from the numerator. I can divide both of these by 3. And this would give me an a plus 3 over 3 would be 1 over the 3 that I had on the bottom. Now these 3's can cancel and I'm just left with a plus 1.